I thought that was a great one, especially since we're talking about slope for it. So we were learning, there we go, this whole chapter on slope. Some of it is a review from Algebra 1, but we're going back and we're going slow. And the reason we're going to do that is because we need to know, like, to see it, to be able to breathe it, to, like, get it every time we see it. So I want this to be easy because this is a foundation. The great thing, kind of what I explained last time, is that once we get this and we see how our equations work, we see how our graphs work, everything else for the entire rest of the year works exactly the same. Isn't that so nice? It's so nice. So let's build a real firm foundation. If you still feel a little shaky, please contact me. Okay? So last week when we learned about functions, we learned that they had to pass the vertical line test, right? So that meant that when we have our coordinate plane, each x could only have one y value. They couldn't have y values on top. So we're just looking for individual ones. And it's called a function. We also learned that function can also just be another name for f of x or y. We can call it y, especially when we're looking at a line. So if it's got a y in there, we can call it a function for the most part for it. So we're learning those vocabulary, and we learned about slope. So I wrote up here all of these terminology words that all mean the exact same thing. Okay? All of these mean slope. So when you are reading in a word problem, or when they ask you on the ACT or on an exam or a CLEP exam or something, and they use these different terms, you can go, oh, it's just slope. That's all we're talking about. So slope is the same as rate. Rate of change can also be that. A rate of change can also be a ratio. That can also be per, miles per hour, right? Miles per gallon for something. All of that gives us a slope. Same thing, any sort of rate. It can be called the constant of proportionality, which has the letter K. So yeah, let's add another variable in there. Okay, constant of proportionality. Why would they say that? Am I going up at a constant rate? Yes, it's a constant of proportionality. Why would they call it proportionality? Because, I've got an extra one here. Because every fraction is a proportion, right? So again, we're just using the same words and describing different things. It's also called M. We learned that was for slope. It can be called unit ratio, and it can also be called direct variation. So again, we have something. Why is it direct variation? Variation means a change between something and the next. So between this x and this y is going to be directly related between this x and this y, as you go across. So direct variation. So all of these things, I'm going to leave them up here, mean the exact same thing. It's important that we get our heads around that language. Remember, we were talking about that. Okay, so who had fun doing the online activities? You didn't like them at all? You'd rather paper?
I don't know if I'd rather paper, but the online was not my favorite, that's for sure.
Oh, okay, all right. So
I was really confused with how to get to it and stuff.
Okay, was the link not working?
Not really. We've had a lot of internet problems though. So
okay.
That could be part of it.
Well, good to know. So with the Google Classroom one, if you weren't able to get on it last week, I encourage you to go ahead and get on it. I'll just, once it's done, we'll get a grade in for it. But hopefully just visually we're able to see some different things, move things around. I know you were able to get on the marble slide on Desmos. I think it has to let you in, and I was gone on vacation. Or a trip.
I think I got in at one point, but I didn't have time to do it, and then I got back on it, and it was being weird.
Okay. So with all of that, we're just I'm trying to get your eyes and your hands on how lines move. How things move according to what the numbers are. And so like with the Desmos one, a lot of it was, okay, which number do I have to change? And so then you start going, I need it tilted more this way, I have to make my number higher. I need it tilted down, I need to make my number lower. So it's all that practice of how does it move, you know. Even in life, like whenever, I know you bake and you do car stuff, you know, and so there's things that's like, well, if I add a little bit more of this, what will that do? And then you just know after time, oh, I know that when I add a little bit more baking soda, like I might get a better rise. Or when I add this, or it's like, oh, well, if I tune my engine, if I use a little different oil, then I get better gas mileage. Like you just learn that over time as you're tweaking it. So that's kind of what we're doing with slope. And we did so many of them because we need to start seeing it, okay? So we're going to take what we knew about slope last week and how it moves lines, and we're going to put it into numbers and into an equation on paper. And then we're going to start moving it all around. And we have 4 different formats that we're going to learn this week. Everyone should have a linear equation review book that I printed for you. You should also have your coordinate planes because we will be graphing a lot today, and you can either come up to the board or you can graph it on your little coordinate plane. I have given a couple other handouts that you're welcome to have for your book, a linear equations handout, and then one that will go over the different forms that we've got today. So just lots of extra little hands-on things for you to look at to see, but we're going to work through our linear equations review book. It is part of your homework for this week, and we're going to fill in parts of it, and then to finish filling it in is going to be your homework, right? And this can go in your interactive notebook when you're finished with it, so it is a great guide that you can use for it. And the one thing that I want us to see as we're going through today, and stop if you have questions, is that we are going to learn one thing in 4 different ways, okay? So in the same way that you guys call me Miss Thomas, my husband calls me Shauna, my boys call me Mom, my best friend calls me Shay, like same person, lots of different names, we're gonna learn the same thing, lots of different, it's gonna look a lot different. So we need to get familiar moving things around because most likely you're going to find one way that looks the best for you. And then to know how to move an equation into that so you can plot it is going to be the ultimate goal. Let's find the way that you're like, I know what that looks like, because what we really want to do is make a picture. We want to be able to look at those variables, look at those numbers, make a picture, and predict stuff from it, okay? And be able to answer word problems. So that's all we're doing. So just to review, we did functions, we talked about that. We talked about slope. What direction does slope go? It is your rise over your run. So your change in which axis?
Y.
Change in Y
Over
our change in X. Okay, so there's 4 different slopes. We made our little slope dude. Our first slope is positive, so we can be going up. What if we're going down? What's that called?
Well,
Negative. Okay. If it's straight up and down?
Vertical.
But it has what type of slope does it have? Remember our slope dude?
Oh, it wouldn't just be.
It'd be undefined.
Undefined. Because is that a function? Why is it not a function?
Because you can put a vertical line through it
And it hits every line, right?
Yeah.
Not a function. That's why it's undefined. It
Well,
cannot be defined as a function.
We're supposed to turn in that slope dude.
No, he's just supposed to be in your notebook.
Yeah. Okay. That's what
And if it's flat, what kind of slope is that?
horizontal.
It's horizontal. So every horizontal line has a slope of
0.
0. None. It doesn't have a slope. It's not negative. It's not positive. It's just 0. Right? Okay. So we've got rise over run. We always need to go in the same order. Rise, then run. So Y, then X is the main part of it. We also learned that if our slopes are exactly the same, so if I have 2 slopes and they're both at a 2,
Parallel.
my lines are parallel. Okay? Now, if I take my slope and I do my reciprocal, my negative reciprocal, so I've got one positive and one negative,
Perpendicular.
my lines are perpendicular. Okay? So those are the two ways that we can find that. We also talked through the different ways to find slope. There were 5 different ways that we could find slope. Specifically from a table, we had the change. We went from each one and we saw, do we have a constant change? Constant of proportionality, direct variation here, so we see that. We found our slope, and then we can plug in values. So initially, we were just looking at everything to find the slope. So how do we make an equation for that? That's what we're going to learn this week, okay? So if we know the slope and we know the y-intercept, what is the y-intercept?
Where the slope crosses the y-plane.
Where your line or your graph, your picture, whatever it is, wherever it crosses the y-axis. Exactly, your y-intercept. It is intercepting the y-axis at that point. So that's going to be the y-intercept. So if we know the slope and we know where our picture crosses the y-axis, we can write an equation for that line every single time. And it is called the slope-intercept form. So in your little book, on that front page, the top one, slope formula, we know that slope is y2 minus y1 over x2 minus x1. That's our slope formula.
Wait, topic 3?
No, topic 1. Formula's at the very front. Did you? There you go. Okay, so we know our slope form. Now, it doesn't really matter. We talked about also it didn't really matter what order you put the coordinates in, as long as you choose this same coordinate for the first one and the same coordinate for the second one. Slope formula, yeah. So change in y over change in x from 2 different coordinate points. Remember, coordinates are always written. We're going to be talking a lot about coordinates and writing everything out. And then we would pick one. So 2 different points. As long as we have 2 points, we can draw a line on anything, this point. So 2 points give us a line, 3 points give us a parabola, a curve, 4 points give us a cubed equation. So so again, we're figuring out those different things. We've talked about that like with exponents. So now when drawing, we actually just need one more.
Yeah.
So we have 2 points, we can get a line for anything like that, okay? So slope-intercept is y equals mx plus b. So that's number 2 in your little book.
That was what we used most of Algebra 1.
Yes. This should be very familiar with you. Y equals mx plus b. As long as you have an equation in this form, you know where it crosses the y-axis, and you can count to any other points on it, forward or backwards, to find where it needs to go. Okay? So, if we have these, okay, let's write the equation. What would be the equation for this first guy? If the slope is -2 and y-intercept is 3, I'd like you to use your little whiteboards that you've got and graph it on there. So we're going to mark. What's the very first place we're going to mark?
The y-intercept.
Y-intercept. When we write our y-intercept, we write it as a coordinate, and it is answering the question when x equals 0. So when x equals 0, we're going to plug in a 0. Y equals 3. So this is a coordinate that we have, 0, +3. So 0, 3, remember it's on the y-axis. So 0, 3, I'm going to go 1, 2, 3. There would be my very first point. Our y-intercept is always our vertical axis here. Now, from 0, 3, I'm going to do what?
Go down 2 and over 1.
Yes, so -2 is really -2 over 1. So down 2 over 1. There's another 1 point. I could even do another one if I wanted to. And I'm going to have a line. Right? So there's my very quick graph that I can do. And then let's plug it in and make our equation for it. Y equals m. What is our m value?
-2.
-2. Okay. 2x, negative 2x, sorry, minus 2x plus b. mx plus b, y equals mx plus b. So b is positive 3, so we're going to put positive 3 in there. Y equals negative 2x plus 3 would be the equation of this line. So that's this line's name. Right? Let's do this other one at the top. Right? So what is our coordinate for our y-intercept?
Negative 1.
Okay, so our coordinate is what? When x equals 0, y equals negative 1. So 0, negative 1 is our coordinate. And we're going to go down 1 for our,
And over 2.
so then from there, where's our slope? Is it going to be positive, negative, undefined, or 0?
Positive.
Positive, so it should be going up. Okay, is it in reference to our parent function? We talked about that last week. Our parent function is that 45-degree line straight through the origin. So is it steeper than our line, or is it shallower than our line? Shallower, because it's a half, right? So these are all our fractions in here, like that. All the way down to 0 are positive fractions. Those are our...
So if the slope is less than 1, it's always negative. If it's more than 1, it's always positive?
No, if it's less than 0, it's negative.
Okay.
So it just means it's shallow. It just means it's not as high of a hill to climb.
Okay.
So what we do is I'm going to constantly be going back to our parent functions, because when we see values, we need to know how to quick graph them. We need, specifically for the ACT, they'll show you something, or when you look at it, you're like, what does it look like? You know, so really quickly, what my goal is for you guys to be able to look at an equation and go, oh, it should look something like that. It doesn't have to be a specific, or, oh, that's down here, it should look something like that. Or that should look something like that. Like where you can quick graph it on to know that should look like this. So in here, we have a slope less than 1, but it's still positive. It just means it's not as steep as our parent function.
Yeah.
So it's a little bit lower. It should be maybe kind of around like that, you know, but there's our parent one, and then we have moved it down negative 1. So there we go.
Yeah.
Should look about like that. And that means we go up 1 over 2. Up 1 over 2. Oh, yeah. Matches. Right? So how would we write this equation?
In which form?
Y in slope intercept. We're just doing slope intercept.
It'd be y equals 1/2 x minus 1.
Perfect. Y equals 1/2 x minus 1. Okay. Now let's look at this guy. Slope of 10, y-intercept of 1/2. What does this line look like?
Steep.
Very steep. This is the Grand Teton, right? Very steep. So in reference to the parent function, we've gone, we're moving up. Okay, is it through the origin? No. Has it been moved up or down?
Up.
Up, but just a smidge.
Yeah.
Just a smidge. Okay, what is the coordinate of our y-intercept here?
Is it 0, 1/2?
Perfect. 0, 1/2. Nailed it. Okay? So I have a really steep line through 1/2. Right there. Right? So if we write this, y equals what?
Y equals 10x plus 1/2.
Perfect. 10x plus 1/2. Okay. What is this last guy? Does he have a special name? Okay. What is our coordinate for our intercept?
The origin.
The origin. Perfect. Okay. What is our slope?
1.
1. Is this our parent function?
Yes.
Yeah. Okay. So he is y equals
0. 1.
Well, Yeah, it
One.
would be.
Do we write 1?
Wouldn't it just
We could
be?
y equals 1x plus 0.
So it could just be y.
Could just be x.
Y equals x.
Yeah.
Yeah.
Y equals x. Y equals x is our parent function. Through the origin, slope of 1, 45-degree angle. That means for every y, I have the same x. If x is 3, y is 3. If x is 10, y is 10.
Yeah. that just
Okay.
continues.
Well done. Okay. So now, okay. So on these, I'm going to have you write, we're going to go through the y-intercept. We're going to plot our y-intercept. So do you want to come to the board or you want to do it on yours?
I'd probably rather do it online.
Okay, do it on yours, and I'll do it up here. Okay, so for this one, my y-intercept is what?
-2.
-2. We write it how?
0, -2.
0, -2. It has to have a coordinate. Okay, 0, -2 is plotted. 0 is my x,
Yep, and then
down 2.
How would you? Oh, so the way that you'd find out the 0 is by when you actually do the line and you see where it crosses the x.
That's for the other intercept. So we are answering the question. So why do we look at this? Okay, when we find our coordinates, and this is perfect question because this is like my next slide for it. We are answering the question when y equals 0, x equals what? That gives us our
So
y-intercept.
it's not asking us what x is.
No, that's our x-intercept. X-intercept answers the question when y equals 0, x equals what? And so all of these are written when y equals 0, x equals what?
it's just the opposite.
Okay? And these are when x equals 0, y equals what? We're plugging in those extras. So on here, when x equals 0, what does 0 do to this entire thing? It gets rid of it. It makes a 0. So when x equals 0, y equals what?
-2.
-2.
Okay, I get it now.
Okay? And we will look again and we'll say when y equals 0, x equals what? And we're solving for x. That will give us our other intercept. We're going to use that with the standard form, okay? So on this one, what kind of slope does he have?
3, 4. So you go.
So is it shallower or steeper than our parent function?
Probably it's a little shallower.
A little shallower, positive or negative?
Positive.
Positive. So my parent function goes right here through these guys, you know, every intersection. So he's going to be about like that, right? But we would move him down to come
Right across the negative.
about right like that. Okay? Okay, so let's do the next one. When x equals 0, we're covering up. When x equals 0, so I'm gonna automatically write my coordinates. When x equals 0, y equals
4.
4. I also know that 4 is my b value. Here's my coordinates. So I'm going to go up 4, 1, 2, 3, 4. My slope is what?
1.
1. Unwritten 1. My slope is 1. So he's at the same angle as the parent function. He's just
Over
straight through all of those lines. Right? Okay, let's do the other guy. What is my y-intercept?
1/2.
1/2. When x equals 0, y equals 1/2. So I'm going to go right there. Up 1. Positive, negative, undefined, or 0?
Positive.
Positive slope. Steeper or shallower than my parent function?
It'd be steeper.
Steeper, because it's bigger than 1, right? So he's a mini mountain. You know, 3. We're going up, so we're going to go to 1/2, and he's going to be steeper. So we can kind of just sketch it in. Okay. This guy. It's my y-intercept. When x equals 0,
Those
y
three.
equals
3.
Negative
-3.
Negative 3.
3. Okay.
Okay? Now, when x equals 1, y also equals
Negative.
3 because I don't have an x value to plug in. When x equals -10, y equals -3. So we are looking at a horizontal line that no matter what x out value I pick,
It's always gonna be negative.
y is always going to be -3. Any questions on those? Are we starting to see
Yeah.
what our numbers actually look like? Okay. Right, so now we are going to rearrange. I'm actually going to go back here because it's cleaner. And then I've got a slide if you want to look at it at home. So the next thing is when we have our slope-intercept form, okay? We like to have it with y on one side, x on the other side, and then our value. We're going to get, because we're trying to get y all by itself, right? This is function notation. We could have rewritten all of those where it says f of x instead of y. Okay, same thing, all means the same thing. Now, what if we rearrange this equation? So we're just going to use our math values. I'm like, I don't like it like this. We're going to start with the second one. I want my x and y on the same side. Okay, what would I do to get my x and y on the same side?
You just minus x.
Okay, so I'm subtract x. So now I have -x plus y equals 4. Right? Now the number one rule is this guy is preferred. We're not going to lead with a negative or with a fraction. Okay, so I can get rid of him by multiplying the entire thing by a negative and say x minus y equals -4. Do you agree with me
Yes.
on that one? Okay. Same equation. This is slope-intercept form. This is standard form. Okay. So in our little booklet, we're going to write on standard form that it is ax plus by is equal to c is the format that we use. Okay. It just means that there's a coefficient of x. He's our first guy, so he gets the first letter in the alphabet. There's a coefficient of y. He's our second guy. He gets the second letter in the alphabet. And some constant, meaning that's our value. Sometimes this constant can be 0. That's fine. Okay? So same exact equation. So I could say that if I have this line, y equals x plus 4, we're going to do 4. I've got my parent. I didn't draw that very well. Woo, there we go.
So the
Parent function through there. I could call this line y equals x plus 4. I can also call this line x minus y equals -4. Same exact line.
even though it goes through +4.
But this doesn't tell us what it goes through because it's not in slope-intercept. If I solve for y, it changes it back.
Right.
This is standard form, x and y. Okay? Now, a shortcut trick is when we look at standard form, if we are trying to find slope, we look at slope-intercept form, it's super easy to know what the slope is, correct?
Yeah.
I look at my slope-intercept form and I can say my slope is 1, right? When we have it in standard form, our slope is equal to -a over b. This is a shortcut for it, okay? Why? Let's think about it. For me to get my y all by itself, to get back to here, I have to move sides for the x. What happens when we change sides? Change sides, we
Change sign.
change signs. So whatever my a was, he got his sign changed. Okay, so see where we got our negative a?
Yeah.
Okay, once he's on the other side, can I have a coefficient of y? Can y have a coefficient over here? So if he did, we would want to get rid of him. How is he attached to the y?
Multiplication.
By multiplication. So the inverse is division. So we would have to divide him off, which means if I divide on one side, I have to divide the whole other side, division by that.
Yeah.
Okay, so this is a shortcut way without reworking it all the way out, where I can say my slope is negative a over b. So let's look at this. Negative a is negative 1, b is actually negative 1, right?
Yeah, because
Minus 1, the sign goes with him.
Yeah.
Negative 1 gives me 1. We have the same slope?
Mm-hmm.
Yes. Yes, we do. Okay, so standard form. So let's rearrange a couple of these others into standard form. Right? So we've got this guy here. Y equals 3x plus 1/2. So we were here. We know we have a slope of 3. I'm able to quick graph him. Slope, y-intercept, slope of 3. We're going to rearrange him. Number 1 rule, x and y have to be on the same side. We're going to move x over and get 3x plus y equals 1/2. We agree?
Yes.
Okay. Is it okay to have this negative 3? No. Okay, so we're going to multiply the whole thing through by a negative and have 3x minus y equals negative 1/2. Okay, same exact line. We could rewrite this as 3x minus y equals negative 1/2. Okay, now, there are some people that in standard form don't like any fraction ever, no matter where it's at. How can I get rid of this fraction? What math rule could I use? Remember, we can do anything to any equation as long as we do it to both sides. So how would I get rid of a 2 on the bottom? A 2 that is divided.
You'd multiply by 1/2, or the reciprocal.
So I would multiply by
2 over 1.
2, right? So if we multiplied this entire equation by 2, 2 times 3 is 6x, 2 times negative 1.
Well, I guess it's negative 2, wouldn't it be?
Yep,
So it's just y.
yep. Negative 1/2 times 2,
2.
Oh.
Oh, wait.
those cancel, right?
Well, wouldn't it be negative 2 if it's a reciprocal? Would we multiply?
But then that would give me a negative up here, which I don't want.
Yeah.
So you don't have to do a negative.
No, the negative doesn't, the only negative matters on our a value.
Okay.
So then I would have negative 1, right? These are all exactly the same line. Different ways. We've just used our math
Yes,
rules
yeah.
to rearrange it. So let's see. What is our shortcut for slope? Okay. What is a?
6.
Okay. It's negative a, negative 6. What is b?
2, negative 2.
Negative 2. Slope is 3.
Yeah.
Slope is
Just go
3.
right back to it.
Okay, let's look this way. Negative a over b. A is
Negative 3.
3, so positive 3. B is 1. Slope is 3. They're all exactly the same. Making sense?
Yeah.
Okay, now let's do this top one because it's a little bit harder. Okay, so first rule, x and y on the same side. What do we need to do?
Get
Yeah,
x on
move
that
X.
side.
Okay, we're going to change sides, so we change his sign. He's now negative 3/4 x plus y equals negative 2. Now we have a problem because he is both negative and a fraction.
Yeah.
Okay, how do we get rid of the fraction, the denominator? We have a divided by 4. So we are going to multiply by 4. Now, can we do it in 2 steps? Because I have a negative, and I want him to be a positive. So I'm also going to... So then if I multiply by negative 4, I get rid of both my negative and my 4 at the exact same time. So let's do that. Negative 4 times negative 3/4, our 4's cancel.
Just 3.
3x. Okay? Negative 4 times y.
What did it be, negative 4?
Yep.
Y.
Negative 4y.
And then negative, or 8.
Positive 8. Okay? 3x minus 4y equals 8. Standard form of this one. Okay? Slope here 3/4. Slope here. Negative a over b.
Then it would be negative.
Wait, so that's slope formula? Is what we're doing right
This is point slope.
now? Okay.
I'm just showing you a shortcut way to get slope. You can write it next to.
What should be the formula for point slope form?
We're not there
Oh, we
yet.
haven't done that.
This is next to slope intercept, or to standard form.
Yeah.
You can write a note that m is equal to negative a over b, just off to the side. You got bonus content for another way for you to quick graph without actually having to work the whole thing out. Now, if they give me a point, if they give me 2x minus 4y equals 6, and I'm just trying to figure out what, and they say match the line, okay? And they, or tell me is the slope positive, negative, undefined, or 0 at that point. I can solve for y. Move the x over negative 4y equals negative 2x plus 6. Divide by negative 4. Divide by negative 4. Y equals 1/2 x minus 3/2. I can solve, oh, my slope is 1/2. I can do all of that work. What I am giving you guys is when they say, here's your standard equation, match a line, what direction does it go? You can go negative 2 over negative 4. Oh, my slope's 1/2. It's got to be positive. Without doing all of the work of actually solving for the y.
Which is nice.
Okay? So that's where we're headed. Remember, we want to make a picture out of what we have. So we're doing everything that we can to find that picture in the easiest way that we can find. Okay? So these are slides that show the same thing. Okay? Everything about standard form. Okay, now, why would we use standard form? What is it also beneficial for? Okay. Standard form is the best way to find 2 points, right? How many points do we need to graph this line? 2. We need 2 points to graph the line. So, if we have standard form, we don't have a y-intercept and a slope where we count up and we find our extra point. We can just go ahead and find 2 points. The 2 points that we find are the very special intercepts. It gives us the x-intercept and it gives us the y-intercept. So when we have this one, 2x plus 3y equals 12, I could say my slope is what? We just learned, how would I find my slope? What is my slope on this guy? Negative 2 over 3, right? Negative a over b. Okay, so my slope is negative 2/3. What direction does my line go?
2 up. Or wait.
He's negative.
Yeah.
He goes down. Okay, so automatically I know that guy goes like that.
Yeah.
Okay, visually I already got a picture of what he looks like. Okay, our standard form gives us 2 points in which to graph it. All right, so what points does it give us? Well, we're going to answer those questions when x equals 0 and when y equals 0. Standard form gives us our intercepts. So when x equals 0, so I'm going to put a 0 right here for x. When x equals 0, y equals what? Well, I've got 3y equals 12. So how do I get y by itself?
You divide by 3.
Divide by 3. So y equals 12 divided by 3.
4.
Yeah.
4. So I've got that guy. Now I'm going to switch. When y equals 0, so right away when we have standard form, we can write our 2 coordinate points. We're going to put 0 in the x, 0 in the y. We're just answering those questions. I say it out loud, like say it out loud at house too. When y equals 0, x equals 2x equals 12. So x equals
6.
6. Perfect. Now I have 2 coordinate points. I've got 0, 4. Plot that on your paper. Where would 0, 4 go?
About 4. On the,
At the origin.
At the origin, we're going to go, what direction? Up.
Yeah.
Up 4. Now I've got 6, 0. So that's
6 count.
over. Okay. Now 6, 0, is that along the y-axis? No, it's along the x-axis. So x and y. So we've got one place it crosses the y-axis, one place it crosses the x-axis. We should always have a point on each axis. Okay? So I've got 0, 4 right here. I have 6, 0 over here. I've got my line that goes through it. Does it look kind of like what I drew?
Yeah.
It's
Similar.
similar. Yeah. It's just moved.
Yeah.
Just moved up. Great. Okay. So, if you still have trouble plotting on a coordinate plane, I encourage you to do some practice for that. Just write out a bunch of different coordinates and think about where to plot them so that really quickly you know this is x, this is y, this is where I move on it. Okay? So, our standard form always gives us those. Right? So we're answering the question when x equals 0 and when y equals 0. We're going to plug those in. Okay? Now, when we change from standard form to slope-intercept form, all we're doing is solving for y. So we kind of talked through that, remember? So it's the exact same equations. We just keep rearranging them in different ways. Right? So we know we've learned slope-intercept, we've learned standard form. There's a third one called point-slope form. Point-slope is y minus y1. This can go in your book. On number 4, y minus y1 equals mx minus x1. Okay. And we can look at that and go, something totally brand new. Uh-oh. What do I do for it? But is it brand new?
No, it's
No.
the same thing.
It's the same thing. We are just rearranging a bunch of things. What's great is God has a lot of order, and so when we do this, we're like, oh, it's the same thing over and again. So where did this come from? So we understand slope-intercept and standard form and how they got connected, right? They're just rearranging what side it's on. Where did this guy come from? Well, what do we know about slope? Slope is some value of y minus the other value of y, and some value of x minus the other value of x. What if we cross multiply those guys? Because we know when we have an equal sign with 2 ratios, we can cross multiply, right? So if I cross multiply, I have x2 minus x1 times m, right? Those two, and 1 times, I'm not going to write the 1, y2 minus y1. Well, what if we already know one of the values and we're just looking for the other? So I'm going to take away my 2 and go, I know that point. Ha! Now they're in a different order. Does that look like our new point slope? Y minus y1 equals mx minus x1?
Yeah.
Yeah. All it is our slope formula that they just cross multiplied. That's where it came from. So it's not brand new. It's just going back to the slope and going, one of these guys we know and the other guy we don't know. And versus putting different letters in there, they just have the subscripts of the one. So again, not something brand new. It's just our slope formula. So why would we use point slope? Point slope is used if we know the slope and we know a point that it goes through that doesn't happen to be the y-intercept. Now, if the point that we know is the y-intercept, would we use this formula? No. We would use slope-intercept. And just because we don't have to plug in a 0. But let's think about that too. If we know that the point that it goes through is 4, and so I say y minus the y that I know equals, and we'll say slope of 3. 3x minus 0. This is y minus 4 equals 3x. If I move it over, y equals 3x plus 4. So we can see that we can use it that way. You can always use it. That's the great thing is all of these equations should get you the exact same answer for all 4 of them. Every single time. It just depends on what you're plugging in and what ones are faster. Okay? So, we've seen that point slope is not new. We've just rearranged our slope formula. It says, so let's look at this one. What is the equation for a line that passes through 2, 3, so it doesn't pass through either intercept? So we can't plug it into slope-intercept form. We can't plug it into standard form. And it has a slope of -1/2. So quick graph. We've got 2, 3. He's about right there. And I've got a line going down like that. Okay? He should look like this. We're going to plug it in. Y minus, now let's label these first. Our 2 is what value? X or Y? X and Y. I always encourage putting an X and a Y above all of them, just so that you don't get mixed up with it. So Y minus 3, the Y's have to go together. Now, here is something else that I'm going to highly encourage, is using a parentheses. Because what if Y was -3?
Then it would be positive.
Would it be easy to go Y minus, oh, there's a -3, there's my -3.
Yeah.
It would be easy to write that, but what it really is it's Y minus a -3, which is the same as Y plus 3. Okay, so when we have negative values, I will always say use a parentheses around your negative value. That way you don't lose your negative. So in this case, we've got Y minus 3 equals, they told us our slope is -1/2, X minus 2. Okay, completely acceptable line for equation for that line. Okay, we can also work this out. Let's work it out. We've got something that needs to be, which of our 4? Commutative, associative, identity, distributive, 5, inverse. Which of PEMDAS do we need to do here as well?
We need to get slope, right?
Well, they gave us our slope. We
So
just
need
don't like this
Y by
form.
itself.
We need Y by itself to get in slope-intercept form.
And we'll need the X minus 2.
Okay. So what do we need to do with this slope?
Do we distribute it?
Perfect. We're going to distribute him to both guys, right? So I have Y minus 3 equals
-1/2 X plus 1.
1. Okay. Now, so
Can you just add?
Y wants to go to the movies by himself. We can think about that. We distributed. Are there any extra parts we need to combine?
Add 3 to 1.
No. We're going to get rid of the easy guy. Y equals -1/2 X plus 4. So now I know my y-intercept is what? What is this value?
4.
0, 4.
My slope is 1. -1.
Okay. My slope is -1/2. It's going down there. I want to know what my x-intercept is. I want him in standard form. How do I move this guy to standard form? Standard form means
X on the other side.
X. Perfect. So we're going to move, change sides, change his sign. Okay. What's the problem?
It's a fraction.
He's a fraction. We get rid of a fraction by multiplying the whole thing by the denominator.
Equals by 2.
So
Okay.
it's just 1x or x.
So I have x plus
y
2y
Equals 8.
equals 8. Okay? Point slope form, slope intercept form, standard form. Same line. Slope is -1/2. Y-intercept is 0, 4. What is our x-intercept? X-intercept answers the question
8.
when y equals 0. When y equals 0, x equals
8.
perfect. Were we able to find our x-intercept easily from this guy up here? No. A little harder from this one. We'd have to solve. We set this equal to 0, rearrange and solve for x. Really easy to solve it from this one. Okay, so they each have their own value in what to find. Okay, is that making sense? Okay. Okay, so we are going. I'm not going to do that one yet. Okay. When you are asked. This one, we're going to do this top one. Write the equation of a line that passes through 3, 2 and is perpendicular to this line. Okay, so we've got to work through different things. What do we have? Do we know the slope?
Yes.
Okay.
Yeah,
We
don't
do.
we?
So
Yeah.
first, let's quick graph what we actually have. On your papers, graph y equals negative 3x plus 2. Okay. Where's our y-intercept?
2.
0, 2. Okay. Our slope is what?
Negative 3.
Negative 3. Down 3 over 1. He is steeper than the parent function. He's got a negative slope. He's going down. Right? Does your graph kind of look like mine?
Yeah.
Great. So here's a guy. They're asking me, I want something that's perpendicular. That means he's going to have to go. I'm going to grab your. No, you have black. Grab a different color here. He's got to go this direction in some format, right, to make a 90-degree angle.
Yeah.
So he's going to be positive. Is he going to be as steep as this guy? No. He's actually shallower for it, so that's what we're looking at. And it says he passes through the point 3, 2. This line crosses it, okay? So the first thing we need to know his slope. We have 1 point. So of our equations, would we use slope-intercept? No, because we don't know where he's crossing. Could we use point slope? We have a point. Could we figure out his slope? Yes, we have 1 point, so we're going to use point slope format. Point slope format, we can look at our thing and say it is y minus y1 equals mx minus x1. Okay, so what is his slope? I've got my point, x and y. It's perpendicular. Remember, perpendicular means I need the negative reciprocal. So if our first guy is negative 3, our perpendicular slope is 1/3. So we're going to change the sign, right? Because if one's negative, the other one's positive. We can see that visually. If one is, and then we need our reciprocal, 3 and 1/3. So now we can go ahead and plug him in. We have y minus, what is our y value? 2. Y minus 2 equals our slope, 1/3 times x minus 3. So here we go. We've plugged it in. Y minus 2 equals 1/3 x minus 3. Do we like this? Look, no. Let's make him into our slope-intercept form. We're going to distribute our 1/3 across. Y minus 2 equals 1/3 x minus 1. Okay? Now we're going to move our 2 over. Y equals 1/3 x plus 1. You actually drew it really close on our graph, right? Here we go, Ramos. Right through there?
Yeah.
Right? So here's our slope intercept for our perpendicular line. we can write our standard form, moving the x over. Do we like it in this form? Negative 1/3 x plus y equals 1. What are we going to do to him? Multiply by 3 and
the negatives.
and a negative. So we get x minus 3y equals negative 3. There's our standard form. So it tells us our two different intercepts. We already know that when y equals 0, x equals what? Negative 3. So there's our x-intercept. We knew that our y-intercept from here should be 1 when x equals 0, y equals negative 3 divided by negative 3 equals 1. Yes.
Okay.
We got the same thing both places. It should always be consistent, no matter where we go. Okay, now, what if you are given 2 points? Right? It goes through negative 1, 1, and 2, 4. Okay? Write an equation of line that goes through negative 1, 1, and 2, 4. Okay? Do we have an intercept? Are either of these an intercept?
Nope.
No. Okay? Do we have our slope?
Yes. Well.
We can get our slope.
We don't have it.
We don't have it. Could we get it?
Yes.
Yes. When you have 2 points,
Well, wouldn't it just be 1?
you have to use your point to find your slope first. So which one? Let's pick this guy as our first value. Oh, no shoes. Okay. So to find slope, we'd have 4 minus 1, our change in our y, divided by 2 minus negative 1. So I have 3. 3 over 3. Slope of 1. Okay. So now I have my slope. So now we can pick. When you are given 2 values, just pick one. So we're going to use y minus, which coordinate do you want to pick? This one? Right. So y minus 1, there's our y value, this is our x value, here's our y value, equals our slope, 1, x minus negative 1. Okay? Minus is a part of the equation, negative 1 is our actual coordinate, so I've used the parentheses there. So we've got y minus 1 equals x plus 1.
Yeah.
Do you agree this turns into x plus 1?
Yeah.
Okay, and the 1 I don't need to distribute. So I've got y equals x plus 2, because we add 1 to both sides.
Yeah.
So here's our equation of this line. So if we graphed it, where is our y-intercept? Y-intercept answers the question when x equals 0, y equals 2. So our y-intercept would be 2. So first I want you to plot negative 1, 1 on your graph. I want you to plot 2, 4 on your graph. And draw a line through it. Okay, remember that we go x first, then y. So negative 1, we're going left first, then up 1 for y. So our first point should be there, negative 1, 1. 2, 4, x first, so 2, then up 4. Right? Make our line through. Does it cross at 0, 2?
Yes.
Yeah, perfect. Okay. Where does it cross the x-axis? What is the x-intercept?
It'd be
X-intercept answers the question what? When
Y equals
Y
0.
y equals 0, x equals What?
One.
When y equals 0.
X equals -2.
Oh.
Solve for x. Change side to x equals -2. Does that match your graph? If you were to
Yes.
extend your line,
Yep.
would it go through -2, 0?
Mm-hmm.
Yeah.
About right here? Yeah, it would. So all of our stuff makes sense. Okay. So we can find an equation for any line, no matter what they've given us. How many points have they given us? Whether they've given us slope in 1 point, whether they've given us slope in a y-intercept, whether they've just given us 2 points, we can change back and forth all around. Okay? So in your book, when you go on, so that topic 2 where it says slope, okay, for 1, 2, 3, and 4, you're just going to write what that slope is. Okay, so you're going to find 1 point, go up, and then go over to find it, okay? For number 3, on the number 1, I want you to write these 2 coordinate points.
On number 3.
On topic 3. -4, -1, and -2, -5. And I do have these on your homework one.
Wait, write those under
printed out.
number 1.
So for number 1 under topic 3, where it says find the slope of these given ordered pairs, this is the ordered pair for number 1. Okay. The ordered pair for number 2 is 2, 1, and 8, 9. The ordered pair for number 3 is 9, -4, 1, -4. And we're going to pause right here. What is something that you notice about these 2 coordinate points when you look at them? Do you notice anything about these 2 coordinate points? 9, -4, 1, -4.
Can't that not be a real, or it's the same y?
Plot it. Use your graph. Plot those real quick. X first.
It's a, it's not a slope, it's just a horizontal line.
X first. X first.
It's not a slope, it's just a horizontal line.
It's a horizontal line, so its slope is what?
It doesn't have one, right? Or it's, well,
Horizontal lines have a slope of slope, dude.
I guess I'm, because, well, straight up's undefined though.
Mm-hmm. But it's not straight up and down. Pull out your slope, dude. Look at your notebook.
Wouldn't it be undefined since it's
It's not up and down. X and Y. 9, -4, 1, 1, -4. Okay?
Is it, I mean, it's,
Slope of.
isn't it infinitely positive?
Mm-mm. No, it's a straight horizontal line. If you're riding your bike, this is riding across Oklahoma.
Yeah.
So our slope is 0.
Okay.
No slope. 0. Slope is 0.
Okay.
Okay? So your slope, dude, will show that. Your slope is 0. So when we are looking at coordinate points, what do we can notice when my y values are the same, my slope's 0. Every single time. Right? Okay. So let's look at number 4. -7, 8. -7, 5.
This is number 4 for the topic.
Number 4 for your topic. Plot those guys real quick.
Wouldn't it just be undefined? So for the same x value, it's always undefined?
If x is -7 and y is 8, and x is -7 and y is 5, when my x values are the same, I have a vertical line, which means my slope is undefined. Okay? Vertical line, undefined, x values the same. This also goes with 2.1 where we said whenever we have coordinates and we have matching x values, it's not a function. Right? So this also satisfies that definition that matching x values for two different y values is not a function. This is obviously not a function. It does not pass the vertical line test. Right? Does that make sense?
Yeah.
Okay. So let's look at so then for the other ones, for topic 4 and 5 and 6, those are going to you will find those in your homework to fill in the rest of that, and then I want you to actually solve them. Okay? So just figure that out. You don't have to figure it out. It will be on there. Write it on there. Right, okay. So something else that we need to look at. So 2.5 talks about correlation and lines of regression and best fitting lines. And we can plug all of this into our graphing calculator and figure out all the details for that in our setting of homeschool co-op and learning lots in 1 week and my definition of preparing you for the ACT. You do not need to do that on the ACT. So if you plan on going into further math and being able to actually write a line of regression, I will teach you that for it. What you do need to know is what is the trend pattern, okay? And then to be able to match a graph, maybe with lines that they've given you, but we've already just learned how to quit graph lines, so then we could figure that out. So best fit lines and lines of correlation means you are given data that doesn't line up on an exact line. It's just trending in a certain direction. So if we were to look at our purple guys over here, and I've got data points, these guys are trending up, right? If I drew a line down the center of them, I would say this would have a positive trend or a positive correlation, right? So my orange guys would be a negative correlation. Now my green guys, is there any way that I can draw a line through them that kind of sums up what they look like?
I mean, not really.
Not really. Great answer. This has no, you just say it has no correlation. Okay? So it can be positive, it can be negative, there can be none for it. Now, how would we do that? Typically, when you are given lots of data points and you've given plots on it, what you're wanting to do is you're going to pick 2 points that you can connect that make that line have the same number of points on one side as on the other side. So we're trying to draw it down the middle is all that we're trying to do for it. Now, if they gave you plots like this and we labeled them A, B, and C, and they said, which data plots best address this line? Where would this line best fit? Would you say it would go with A, B, or C? Okay, well, right away, we're going to look at it and say this line has a slope of what?
-2.
-2. So it is negative. We know that line has to go that direction. So which of these graphs would it go with?
B.
It would go with B. Okay? If they say there was, we did a study and it was 3x minus 4y equals 12 gave the line of regression or the line of best fit correlation to which graph? We could use this to find two different intercepts, right? We could do that and say when x equals 0, y equals
-4.
3. Well,
-3.
yeah.
When y equals 0, x equals 12 divided by 3.
4.
4. And we could plot those guys. 0, -3, 4, 0. It's going up,
So A.
right? We could also say my slope is -a over b, which is -3 over 4 over -4, which equals 3/4. My slope is positive, negative, or none. Positive. We'd be like, oh, he best fits A. Okay? So, when we have lots of data points and we have equations, this is why it's important to know what do all those values on my equations whenever it's lined up, like ax plus by equals c, or y equals 2x minus 3, to go, oh, I know what that looks like. I can quick sketch that. Oh, he would match this graph. Okay? Line of best fit just means we're putting a line as close as we can, and it is okay to say there's not one. There is no good fit for him. Okay? Now, this is also a homework form for you. We're going to work through some of it here together. We've got a couple more minutes. Okay? So, in this way, this is a great consolidated form of going, we're going to have all of our guys that look exactly the same. Okay, so on this very first one, we've got y equals 1/2 x minus 3. I'm knowing I'm having to graph it. Do we want to go ahead and plot those points and graph it according to slope-intercept? Could we do that?
Yeah.
Yeah. What is my very first point? My y-intercept is going to be, so for,
-3.
okay, and on these, what I want you to do is I do want you to do x-intercept and y-intercept. I want you to label them. X-intercept answers the question when y equals 0. Y-intercept answers the question when x equals 0. So when x equals 0, y equals -3. Okay? So we're gonna write his coordinate point. It's important that we can write that coordinate point. Okay? And so from -3, I'm going to go up 1 over 2, up 1 over 2, up 1 over 2, which means I can also go down 1, back 2, down 1, back 2, and I've got my line. So there's my graph in both directions. From my plotting, I can see that the x-intercept should be 6. Okay? So, the first one to move for me, if I have slope-intercept, it's easier for me to move to standard form. Because standard form just means I have to put everything on the same side. So we're going to put our x with our y, and I'm going to say -1/2 x plus y equals -3. You agree? Okay. Do we like it in this form? No. We're going to do what to the entire equation? Multiply by -2. We're going to get x minus 2y equals 6. Ooh, when y was 0, x is 6. Ah, we got it. It matched. Perfect. Standard form. Y equals x minus 2y equals 6. Okay. Point slope form for this is simply taking our slope that we have here and picking a point. Well, what point do we know exists here? Right?
Yeah.
Isn't 0, -3 a valid point? Because that's the intercept?
Yeah.
Okay? So we can rewrite it as y minus -3 equals slope 1/2 x minus 0. That would be a valid point slope form. Or we would say y plus 3 equals 1/2 x. We could leave it like that too. Okay? We could also go, oh, from my graph, I know that this guy right here is 4, negative 1. So I could say y minus negative 1 equals 1/2 x minus 4. That's also a valid one. Like we can pick any point on the line to plug in for point slope for it to go in there, right? All of these are exactly the same. So let's look at this guy. They give us point slope form. We can solve for either one by just simplifying. So first step, we got to spread everybody out. So we have y minus 2 equals negative 1/2 x. Negative 1/2 times a positive 4 is going to give us a negative in the first place. 4 divided by 2 is?
Negative 2.
2. Great. I'm going to move my 2 over, plus 2, plus 2. Oh, that cancels. So for my slope intercept, I've got y equals negative 1/2 x. Correct?
Yes.
Okay. Then for standard form, I just move them to the same side. So we have 1/2 x plus y equals 0. Don't lose your 0. The 0 stays there. Multiply the whole thing by 2. We get x plus 2y equals 0 would be your standard form. And then we're going to plot it. Right? So we're going to work through and fill in all of our different boxes. Questions? Got it? Okay, so that's it for this week. We're going to spend a lot of time, most of the time in your homework, we just did 2 lessons, or technically 3. But most of your homework is going to be 2.3 and 2.4. That moving back and forth between all of the equations, all of the lines, being able to find slope, find your intercepts. You're going to need to know how to find your x-intercepts and your y-intercepts for each one of them and be able to graph it. Okay, so we're plotting, we're going back and forth. One of my suggestions is even if your homework assignments don't ask you to graph it, is to just quick graph so that you know, because especially like if you're doing the ACT or standardized test, that's like pencil to paper so you at least know what direction it's going, really gets that information out of your head onto there. So always just beside it, quick graph. It's also that extra help of plotting points and knowing which way to go and getting all your points on it first. My recommendation, if you're not on the you're on Desmos, we'll make sure you get into the Desmos.
I think I might be in it.
Okay. Is what's great about Desmos is you can go in on Desmos and put every single one of these equations written like this on 3 different tabs, and it should draw this same line on all of them. So double check your work. After you do the math portion of writing it out, pull up Desmos. And in line 1, put this equation. In line 2, put your other one. In line 3, put that one. And see if it doesn't graph it on the exact line. It'll just graph it for you.
Yeah.
So that's easy. All right.
And our job is also to complete the review.
Yeah, so that's on your homework.
Okay.